All right, so we're gonna talk about antiderivative today for the first time. It's whatever. My bad. All right. Integrals. Yay.
Yeah.
Okay, so also there is a name called antiderivative, which is the opposite of a derivative, or inverse of a derivative to be more precise. And indefinite, there's also another name, indefinite integrations. So let's assume that I have f of x is equal to 3x squared. Can you tell me which function, after you take a derivative, is equal to 3x squared? Can you tell me which function, after you take a derivative, is 3x squared? Good. So we're going to say there's a f of x, which is a capital F of x. Okay, capital F of x is equal to x cubed. Because capital F of x, well, how do you get there? This process is called the antiderivative. So now remember, I use a capital F rather than non-capital F, because if I integral the f of x here, if I integral, let's just say, I can write in two ways. I can write this as integration of f of x dx like this is equal to f of x. Now, there's something else that is coming after this, right? There's something coming after this. Why is that? But it turns out, integration, if I take a derivative, right? If I take a derivative of following things, x cubed, the answer is 3x squared, right? But what about d to the dx of x cubed plus 1?
Just will be 3x squared.
3x squared. What if I have d to the dx of x cubed plus 2? Same thing. So therefore, that is actually has to be something else as well here.
And that's represented by c, or is it just any number?
C. So f of x, capital F of x plus c. Capital F of x plus c. That c is really big. That c is a constant. C could be any number, because derivative of a c is going to go to 0. And then you see why that c is very important. Sometimes people write it in this way. Sometimes people write it in integration of f prime of x like this, but it's capital F of f prime. That's also equal to f of x plus c. That just without capitalization. So if you integration of a capital F prime of x, it's gonna be capital F of x plus c, or a non-capital F of x. So therefore, f of x is same notation as this. This is the same. So notation sometimes get kind of confusing, but just understand f of x is equal to capital F prime of x. Is that okay? Okay. Now, if I says, can you find general solution? But we're going to say what is called general solution again. So general solution General solution of the differential equation of y prime is equal to 2. That means I want to find out what is y is. What do you think y is here?
2x plus c.
Good. Because if you integration of 2 dx, so this is the first time you see this integration notation. This just means the integration. 2 dx is going to be, well, integration of 2 dx is going to be 2x, because derivative of 2x is 2. But don't forget a plus c, because c could be a vertical translations. Because you take it, the c is gone. You're still going to get 2.
And so in there you have integral of 2 and then dx is a separate thing?
Dx is, they
Is
don't
that
gonna,
kind of just distinguishing what variable you use?
here, yes.
Okay.
Because it could be dy, then it'll be y, right? And that's a very good question. Now we can talk about that dx part later. It's gonna be a small changing of x. But yeah, later on we're gonna talk about that in more details. But right now we cannot, because we just want to worry about integrations. So we're gonna using the derivative to find out all the integration rules. But there is only one rule that's very important. We're going to address that, but we're going to address all the integrations first. So let's just say basic integration rules, but start with differentiation rule. So what is d to the dx of c?
0.
Is equal to 0, right? Therefore, what is integration of 0 dx? C. Yeah. Because they have reverse, right? So what's derivative of a kx? Well, that's just k. So what's the integration of kx, k dx? What do you think integration k dx is? Kx plus c. Don't forget the c, because c is important. So this is starting from the basic. Whatever dx to the kf of x. Well, we know that's kf prime of x because we're taking derivative. But what's integration of kf of x here? Dx. Now, one thing that you know, that you can take the k is a constant in this case, so you can take a k out. And you can even write as k of f of x here plus c, because if integration non-capital F, it's going to be a capital F of x plus c. What? What you don't know?
It's here.
Oh. Hey, that.
Alright, strange. Dang it, my muscle memory's been so weird from that, so I was trying to get used to drawing this now.
The integration sign?
Yeah, and also just like dx instead of d over dx. Like, I keep doing it as a fraction.
I did this a fraction too. Okay, so now what we're gonna say is, hey, there's a rule says f of x plus minus g of x. And if you take a derivative of that, it's gonna be f prime of x plus minus g prime of x. You can break up to two separate parts. This is very important, I will say, for today's purpose. It's very useful. So
okay.
the truth is, you can actually break down this to break to two integrals. So let's say break the f of x dx plus integration of g of x dx. And you can break the two separate integrals if you have two separate terms. Very useful, very useful. Yes?
For the previous one with kfx, would it, for the final answer, would it be k and then
capital F.
But would that be in parentheses? Would it be k times c or no?
Oh, you mean k parenthesis f of x plus c?
Or
No.
do you just kind of ignore multiplying k by c because c is ambiguous?
C is C is C. C,
Okay,
it
so-
doesn't matter. You multiply by 2, it's still C.
Okay, so just
C-
no matter what you do to it, it's always c.
Yeah. C data we're going to talk about is the constant of the integration. It doesn't really determine the C is until we have initial conditions. But we don't have initial condition yet because we are dealing with the indefinite integral. Do you guys know how to take a derivative of this? This x to the numerator, what's the derivative of x to the n? Nx what?
To the power of n minus 1.
Now, here's what I'm going to do. Can you predict the rule of integration x to the n? If integration is the inverse of a derivative,
It's x over x. X to the n plus 1 over n
almost.
plus c.
No. What's it?
Oh, I see. Yeah.
No.
Is it x to the n plus 1 over n plus 1?
Yep. And I'm going to show, this is the only thing that is matter. So I'm going to put, this is the main thing here, because I'm going to say this over and over and over again. In integration, I feel like this is a fresh start because a lot of people suck at derivative. And you got it. The reason why you suck is because there is a chain rule, there's a product rule, there's a quotient rule. Sometimes in the question there was a product and chain, quotient and chain, right? It's so many combinations. But in integration, there is only one rule, the power rule, which is this one. This is the only rule that's really matter. It's called power rule. Now, there was an exception to this power rule. I forgot to mention other class. Is n cannot equal to -1 because you cannot take x to the -1 power. The reason why you cannot do that, imagine that x to the -1 dx like this. What will happen if you do that? Well, it's x to the -1 plus 1 over -1 plus 1.
It's 1 over 0.
And that's going to be x to the 0 over 0 plus c. And that's bad. So there was some exception to the rules. You cannot take integration x to the -1 or 1 over x for that matter. And also, how did Ethan come up with this rule? It's not because of anything. He kind of thinking reversely. If I were to take a derivative of x to the n plus 1 over n plus 1, what will happen? The n plus 1 is going to drop in the front, right? And the x to the n plus 1 minus 1 because it's going to subtract 1. The n plus 1 still on the bottom. And this will cancel out. This will cancel out. That's equal to x to the n. So we kind of think about in reverse of what happened. Tony, you're early for one day and late for the rest. Okay, so this is the most important rule here today. There is an exception to the rule. It cannot be -1, but x to the n also in numerator. You only can take an integration if they are in the numerator. They cannot do integration if 1 over x squared. The x squared is on the bottom. You had to move to the top using algebra rule before you integrate. Okay, so that's just all the rules. Now let's talk about trig rule. Well, let's figure out what's integration of cosine of x dx. Shh, Ethan, you're not allowed to talk. Because you're gonna take all the answers. I'm not saying, I'm sorry, Ethan. I want other people to participate.
No,
So
that's fine.
I'm gonna call on like Elaine. And I'm gonna call on like Madeline, who usually don't talk because I don't hear their voice. I don't even know what their voice sound like sometimes. So I wanna call on some people that I usually don't hear a lot. So what's integration of cosine of x, Elaine? Think about what derivative is gonna give you cosine of x. That would give you the answer.
Negative sine.
You're on the right track. But it's not correct yet. But you're on the right track.
So sine.
Right. Very good job. See, you can do it. You just have to believe in yourself. But that voice is very hesitant. It's like, I don't know if I'm right. Just say it with conviction. Negative sign, say a negative sign. So what? You got it wrong. Say it with confidence. It's okay. And then if you're wrong, then just correct it. I'll give you feedback. I say, hey, no, that's not on the right track. And you say, okay, that's sine of x. Say it with conviction, like you own it.
Okay.
Cool. The reason why I know this because derivative of sine of x is equal to cosine of x. Oh, actually, no, you were right at first. Wait, hold on a second. Were you right? Yeah, you integration cosine. Oh yeah, no, you were sine of x is right. Okay, so what about integration of sine of x dx, Madeline? Are you sure? Don't look at that, Kevin. Don't look at Kevin. So okay, yeah, it makes sense, right? Because you think about it, if I take a derivative of the cosine of x, it's going to give you negative sine of x. So therefore, integration of sine of x has to be, if I take a derivative cosine of x, it's going to be negative sine of x. That's not right. So if I take a integration derivative of negative cosine of x, it's going to be negative sine of x, which is positive sine of x. Yep. So because derivative of cosine of x is equal to negative sine of x. So therefore is that. Okay, so that's give you a tricky one. So integration of secant square of x dx. Let me ask Min, what do you think? Integration of secant square of x dx.
Would it be secant x tan of x? Secant x tan x? Plus c?
Simon?
Should be tan x plus c.
Tony? Tony, you missed a very important part. You missed the integration part. You cannot miss any class anymore. This is not. Catherine, what do you think? You wrote back in the notebook. What do you think? Tangent of x is correct. So Simon's correct. Catherine's correct. If you have 10, you have sex twice. Right, Chase?
That's why I have no tan.
He's been abstinent.
So theta dx of 10 of x is equal to secant square of x. Okay, well, what is the integration of cosecant square of x dx? Ding, I never hear his sound. Never hear him talk. Ding.
plus C.
Almost. Almost.
Cosecant cotangent cosecant.
You're getting colder.
And it's cotangent cosecant.
Maddie? Negative cotangent. Good job. Because derivative of cotangent of x is equal to cosecant square of x. Negative. That was really ugly handwriting. Okay, so what is the integration of secant x 10 of x dx? Vincent, what's the integration of secant of x 10 of x? Secant of x plus c is excellent. And for this part, it's derivative of secant of x is equal to secant of x plus tangent of x. Okay, so what's last one? What's integration of cosecant of x, cotangent of x? Aiden? Negative cosecant and cotangent of x dx. If you guys don't remember, make a note card, make an index card, all this rule you need to know. Derivative and integrations. Aiden, come on. Ah, come on. Ethan, okay, you can talk now.
Negative cosecant x plus c.
Negative cosecant x plus c. That's excellent. Because derivative of CSC of x is equal to negative CSC of x, COT of x. Okay, so we know all the integration. Mostly, can you figure out which four I did not mention? Which four integration I did not mention? 10 of x, good. Good, good. So this one is to be continued later. We don't have the correct skill to do integration of those until next chapter. So that's chapter 5 stuff. But it's also not as frequent on AP exam, but for my exam, yes. But it's one of the things that you're supposed to know. Integration, tangent, cotangent, cosecant, and secant. Now, if you're in BC, you're supposed to know this by heart. If you don't know it by heart, then you're pretty much in a bad shape. But later on, we're going to talk about this. So we're going to talk about integration of 3x. So for me, I just take out a 3. Why? Because the constant, I can take it out. I don't take out normally. I can do it in my heart. In my mind, I don't have to write out this extra step. But this extra step to help you to see that 3 is separate on its own, just multiply afterwards. How do I do integration of x? I know you know. Corbin.
Integration of x.
Yeah.
1.
No. That's derivative, Thomas.
I was gonna say 1, so I'm glad
No,
you
it's
said
x squared.
What?
X squared, no?
No. Yes, Aiden?
It would be x squared over 2.
X squared over 2. Thank you, because this is the 1. So what happened is 1 plus 1 over 1 plus 1. Usually I don't write this stuff. I'm going to write it out for the first time and then write out the last time again. And it's right here. And this is the only time I'm going to write it. Because at 1 plus 1, you can do it in your mind. And now over 1 plus 1, you also can write it in your mind as well. So that's very easy. Now remember, x can be only numerator before you take an integral. So you have to do some adjustments sometimes. So what is the integration of 1 over x cubed dx? Now this one I'm going to leave for you to do. Oh no, finish it. Finish your integration. But you have to change something before you take it. You use that power rule first. You have to use your exponent rule first before you do integrations. The exponent rule is very, very important.
That's 2 or 3.
3.
Oh, it's 2.
So you can't really use a power rule in this moment. I'm going to say that again. You cannot use a power rule at this moment. You had to do some adjustment before you use power rule. Yes.
Would be 1 over negative 2 to negative 2x to the second power?
Say that again.
Would it be 1 over negative 2x to the second power?
Yep, that's right. Good job. Corbin, you improve a lot. So, first of all, I cannot take an integral at this moment. I have to use a power rule. I have to use the not power rule, negative exponent rule to change the negative third power dx. The reason why is now I can use the power rule to integrate this. So that's equal to, well, this one is going to be x to the negative 3 plus 1 over negative 3 plus 1. Again, I don't usually write out the step, but you should know that that's negative 2 over negative 2 plus c. I usually go skip to this step and now simplify as well because I don't like the negative 2 power. So it'll be 1 over negative 2 x squared plus c, just like what Corbin told me. Is that okay? Okay. Well, what's the integration of, oh, I'll give you a different one. 2 over third root of x squared. I forgot a dx. Very bad. Bad teacher, bad teacher. Am I streaming? I am streaming. I haven't heard somebody today. I'm gonna call Jack. Jack is being like trying to stay off the radar. Huh? No. No, I'm calling Jack. What do you think your answer is? Everybody agree or disagree? Okay, okay, well, nice. Let's see what if it, how do you do it? So integration of 2 to the x to the 2 over third. That's the first step because that's just a power rule. That's actually a definition of radical. Do you do that? And be 2x to the negative 2 third. And not just algebra. There's no calculus, no nothing involved. There's just algebra. So now negative 2 third plus 1 third, that's going to be x to the 1 third. 2, right? And you can say divided by 1 third. And how do you do that? Keep change flip. So that 1 third gonna become 3 over 1 when you multiply. So it'll be 6x to the 1 third plus c. Does that make sense? Yes.
Are there implicit integrals?
No, but there is a partial integrals. So that this only deal with calc 3.
Oh, okay.
So there was a dx and dy and dz, and there was 3 different variables in the equation. You have to take each individual one integral, and if you do that particular variables, like say x, then you treat as y and z as a constant. And if you do integration of the y, you treat x and z as a constant. and you treat the other way, and vice versa. So it's called triple integrals.
Oh wow.
So yeah, so later on you in Calc 3 you have a triple integral dx dy dz. Yeah. And this is just a very, very foundation building block to get there. Okay, so for those of you guys are engineer future, that is going to deal with that, but not everybody needs that. So we just need algebra calc 1 and to get all the major. So what I would say is like people like Madeline, she's like, I don't know why I'm taking this class. I can see it in her face. But the thing is like most of the major you pick, 99% of the major you pick, it's just need calc 1. So you finish Calc 1, I don't need to see you again. Unless you want to join Calc 2, but she's like, I already suffer enough in Calc 1. Huh? Right. So that's that. Okay, so how do I take an integration of 3x to the 4th minus 5x squared plus x dx? So we can take an integration by itself, like small things, like, you know, just 3x to the 4th, 5x to the 2nd, or just x. We can break them apart and just take integration separately. So this is pretty easy. So integration, yeah, I know you got this, but it's okay. Integration, this is super easy. X to the 4th, just gonna be x to the 5 over 5. Is that okay? Minus 5x to the 3 over 3 plus x squared over 2. This feels like this is easier than algebra 1. Plus it's important. We're gonna talk about in a second why that's important. Now, this one's gonna be kind of challenging. Why is this one challenging? But if you remember what I say when we deal derivative, you will know exactly what to do here. Remember, you only have one rule, power rule. No other rule that you can use. You had to fixate it. That's only rule you can use. There's no quotient rule. There's no nothing. So there is something around it though. Bless you.
Thank you.
Remember, you only can use power rule. How can you make it this to make it only power rule only? No. You cannot get rid of one.
You can move it up and then separate them into two separate integrals and then multiply those two integrals together.
I don't prefer. I know your idea, but I don't prefer that. There was a reason why I don't prefer that. I prefer you do this though. Split. I prefer the split. The reason why when you deal with trig, this is better. So I will say this is a much better way to do it. So this means x and x 1/2, right? And this just gonna be 1 over x to the 1/2 dx. And I can simplify this, it's gonna be x to the 1/2. I haven't taken integral yet. X to the negative 1/2 dx. So now I'm gonna integrate this, so it'll be x to the 3 over 2. Now divided by 3 over 2, same thing is keep change flip, so it'll be 2 over 3. Is that okay? Am I going too fast with that? Do we do extra step? Divided by 3 over 2 here. In case of some people says I walk too fast. This is gonna be 1/2 and divided by 1/2, but it's gonna keep change flip. So that's equal to x to 3 over 2, then this one's gonna be 2 over 3, plus x to the 1/2, and this is 2, and then plus c, and this is my final answer here.
Mr. J,
Yeah,
if you had x on the bottom with the whole thing out,
what?
if you had, instead of square root x on the bottom, if you had just x, it wouldn't work, right?
It won't work because that will be 1 over x.
Okay.
And 1 over x, you don't know how to integrate 1 over x yet. Okay, so I'm gonna give you a couple questions. I'm gonna give you x squared plus 1 squared dx. Remember, you only can use power rule. There's no other rule you can around it. So you got x cubed plus 3 over x squared. I can give you another 2. Will be cube root of x times x minus 4. Last one is gonna be x squared, 3x squared plus 2x over square root of x dx. So we got 4 questions. You guys gonna check each other's their work. X cubed plus 3.
The first one says x squared plus 1.
X squared plus 1 square. Parentheses square. But don't kill puppy.
Over x, the second one over x squared.
It's over x squared. Shang. So Shang is sick at home. Parents text me, it's like, says, Mr. Ye, Shang was not feeling well today. He stayed at home, but he wanted to live stream. Does he need Twitch? Huh, Shang?
I would give you my Twitch Prime.
Why do you need a Twitch to watch Mr. Ye's live stream? Maybe Mr. Ye should live stream on Twitch.
Oh,
He just did the thing.
That's funny.
yeah, that one thing.
You just
Shang.
The problem.
I'm almost done. I'm about you finish the other three. The first one? Okay, so you just multiply. You just FOIL.
You foil by plan.
That's obvious.
One.
What?
Because foil, because
Elaine, you kill puppy.
Yeah.
can't believe this.
Please don't kill puppy on first questions. Maddie, did you kill puppy?
No.
Elaine killed puppy. I know we all Chinese people. We eat dogs, but it's okay. See, I can say it. You cannot say it, Corbin.
I can say it around people who won't cancel me, so.
Yeah, but I can say it.
Your face immediately turned red.
Mr. A, would you cancel me?
Maybe some other day.
Some other day. I don't feel safe around Mr. A. This is no longer a safe space. Hold on.
I don't get canceled.
Did you say you don't beat kids?
I won't be.
I don't beat
canceled.
kids.
Oh.
No, I do beat kids.
Yeah, he does beat
Yeah.
kids. You
Yeah, I was
were
about to
beaten
talk-
by him.
I know. I was gonna say that he beat.
He beat me.
For the first one, can you get rid of the one after you pull?
I think beating's good.
No, you don't get rid of the one. The one becomes an X.
Oh,
Plus action.
Yeah.
more.
You should beat your kid.
Ah, Mr. Yeah, you're streaming.
So
You're teaching Sean good. Are you trying to teach Sean's parents?
no.
Just tell them, hey, you need this Twitch Prime thing in order.
I don't
to
know
watch
you.
my
I don't know if
stream."
you watch this comedian. His name is called Russell Peter. He's an Indian comedian, and he was telling like he was telling people like why you need to be your kids. It was really funny.
You need to be your kids.
That's the only part of my job that I missed out on.
I missed that childhood, that great childhood trauma.
My mom hurt me in ways that didn't make sense.
Okay, Sean texts me, says, "Hey, Mr. Ye, I have a screen time and using 1 minute right now. Can you tell my dad what kind of apps?" I'm gonna say not Twitch.
He actually has like.
I stream on King. I don't even think that's a thing.
Smiley face. I know he's not even like what he was. It's so.
For the
What's your like average audience retention?
yeah, that's what I did.
We just bully him.
And then you just do that. You just do the thing that Mr. Ye just taught us.
All right, so the next one is can split this. So that's gonna be integration of x plus 3x x negative 2. So that's gonna x squared over 2 plus 3x to the negative 1 over negative 1 plus c. So it'd be x squared over 2 plus minus 3 over x plus c. Is that okay? Do you guys get that or no? You can distribute this, so that's going to be x to the 1/3 times x minus 4 dx, and you can distribute this x to the 1/3. So if you distribute x to the 1/3, it's going to be x to the 4/3 minus 4x to the 1/3 dx. Oops, my bad. That's bad. What is the x to the 4/3? 7 over 3, 3 over 7, minus 4x to the 4 over 3, 3 over 4. And the 4 cancel out. So 3 over x, 7 over 3, minus 3x to the 4 over 3, plus c. Close? Not yet? Not done?
Wait, yeah, we're 7. Isn't it 5 over 3?
Where's 7?
X to the 5 over 3.
Which one?
Like the 7 at the bottom. How do you get a 7?
Oh, it's 5 over 3?
That's-
Oh, I can't. Yeah, no.
Okay.
1/3, 4/3. Yeah, 4/3 plus 1. 7/3.
It's 4/3 plus 3.
Oh.
4/3 plus 3. It's
4/3 plus. Yeah. Adding fraction. I can add. I can add. Oh, yesterday I was in tutoring SAT section. It was so bad. I was like, 106.5 subtract 99 is equal to 17.5.
Because you divide by.
That's true, man.
Stop.
Remember to add plus C.
Oh, I forgot.
No, I kept reading. I was trying to figure out what it said, and I just read it as I did it.
I forgot every plus C.
Oh, Corbin, all of your stuff was wrong.
And you even wrote down add plus C. Certainly, I'm a moral analyst. I'm not. I decided.
Don't worry, he's consulted you. Nothing new.
I take it back. I take back.
Like normal.
I'm not trying very hard.
You're really not trying. You're also now. Not only are you a bad person, you're also a liar.
No, I'm not a liar.
You said you would try.
I've never lied in my life.
Like makes you feel sick after that.
What? It is not.
Literally, bro.
That big of 96 seconds.
What is that?
Candy corn.
Oh, I'm so weird.
Even this. Ew. You know, 50 though.
I'd rather to me, but yeah, vegetarian.
But this has nothing to do with candy corn, bro.
You know, in like Japan has very good. What's that? Like a sponge? What's that? It's kind of like sponge, white. Huh?
Is it a cake?
No, the sponge, like
You know, like Chinese,
like cute, like
you know, what's going Chinese.
Sponge cube Japanese.
no,
That's
like
what we got,
candy.
like-
It's not candy. It's marshmallow. It's not.
Oh.
Mochi.
But like
Oh.
in Japan, like there's really good ones. Like they break, like they have to.
Dango?
Yeah, you white.
Oh no, dango. Is it called dango?
Oh.
Uh huh. You can come in.